All right, good afternoon, geometry guys. It's Mr. Jeffers coming at you for a 3-day weekend. Yeah. It always used to be really fun when I taught at the other school system and I lived in the district, and I would go by knowing that we didn't have school and seeing kids stopped at the bus stop. Like, because if I had to leave early or do something and I was like, you thought I would have been a nice person, actually told them that we didn't have school, but I didn't. Okay, so a radius is a segment connecting the center of the polygon to one of its vertices, okay? Now, yes, we're going to have some weird verbiage, but, you know, listen to some of y'all's brain rot, and then we'll go from there. All right, so a polygon has the same number of radii as sides. Radii is the plural of radius, okay? They all make congruent triangles. Now, this is kind of something big that we're going to use today. The central angle, okay? We're going to take 360 divided by n, and the n is our number of sides. Now, kind of similar to what we were doing the other day. We're going to use the triangle formed with the radius and the apothem to find the length of the apothem. Yeah, that's a little apothem heavy in that sentence, but there was no other way to say it. Okay. So, let's jump right into it. All right. So, example A. How many sides do we have? 1, 2, 3, 4, 5, 6. We have 6. Yeah, 6, 7. I really wish I was around some of our Spanish-speaking friends to see if the kids go, you know, se siete. Okay, so, I mean, it'd be, if I knew how to say it, you know, in French, I would do that. But I'm a little off on my French on my numbers after un, deux, trois. All right, hang on one second. All right, so central angle. Well, 360 over 6. We get 60 degrees. Now, that means this whole thing right here is 60 degrees. Okay? Now, this type of triangle made, we're talking about what's made with the radius and the apothem right here. Yes. All right, so let's think about it. If this central angle is 60 and we cut it in half, okay, so how much is this angle right here? 30. Okay, so yes, this makes a 30, 60, 90 triangle. All right. So in the rules, it says that the short leg is half of the hypotenuse. Okay, so, all right, if you need to, you can take your shoes off and use your toes to count. But what is half of 4? 2. Okay, good. All right, this long leg is this, the short leg, times the root 3. So this would be 2 root 3. So that's our apothem, is 2 root 3 right here. Okay. Now, our side length is this over here. So if this is 2, what does this length have to be? 2, and the big length is 4. Yes. All right. Now, again, I don't know if y'all have still yet to figure it out, but all these questions that y'all have to answer on all this stuff is your line of thinking that you should be doing when you have these problems. Okay, other than saying, okay, here's your problem, do this, here's your answer. This is how you should be thinking about it. All right. So my perimeter, well, side length is 4. Numbers. So what? 6 times 4? 24. Okay. Which is not as funny as 25. Okay. Now, remember what we talked about yesterday. If there's a square root of 3 right here, we're just going to put that automatically down there for our area. Exactly, with the yawn. Now, and then we're going to take 1/2 times the perimeter, and then just this number 2 of the apothem. Okay. So, oh my gosh.
24.
Yes, times 24 times 2. Yes, it is 24. And that's our answer. Now, this would actually be meters squared. That would be meters. That would be meters. This would be meters. Okay, so now, this is the part that I kept out of yesterday's lesson. Because I did not think cramming it into yesterday's lesson with the other stuff would have been very good. Okay, granted, we're on a Friday, right before a 3-day weekend. We're all tired. Some of y'all have been ready to go home today since yesterday afternoon. Okay, so myself included. Now, so been ready to go since tomorrow. That works for 2. All right. So, number of sides. I wonder how many sides this shape has. 4. Some of y'all are like, this is the kind of questions I get on iReady when I go click, click, click. Okay. So, your central angle. Well, that's talking about this right here. Central angle would be 360 divided by 4, which would be 90 degrees. All right. Now, if we draw the apothem, all right, that just cut that 90 degrees in half. So what is half a 90 degree?
45.
So this is a 45, 90 degree angle. Okay. Now, of course, the idea hit me after I had all this printed out and stuff, but it might be a really good thing for me to put on stuff for Tuesday is our review of what to do for our 30, 60, 90, and 45, 45, 90. Okay. Because I'm pretty sure y'all all have those notes still with you, right, from last semester? Some of y'all are like, yeah, we are. And other people are like, I know where I put it in the trash can a couple of weeks ago. But anyways, that would be my luck. I would have thrown something away. Not saying that any of y'all would ever have that happen to them. Okay. So our apothem. All right, if we're given the hypotenuse of 6 root 2, our little a is going to be actually this divided by root 2. Okay, so what happens to these root 2's? They cancel. Okay, so if this is 6, this side's also 6. Yes, that does mean the side length is 12. Okay, so if the side, what in the heck is that you're trying to, please let's not try to draw creepy things on the board in class. Okay, now, yeah. Like I said. Okay, anywho, now the perimeter is 4 times the length of the side. So what is 4 times 12? 48. So this, our area would be 1/2. 6 times 48. All right, so it's 144. Now, this one we didn't have a unit of measure. Okay. But, there we go. Again, after today, I might only ask you'll see on the last 2 on the back of the page. But once you can find the area, I wouldn't have on a test, I wouldn't have one problem with what we did yesterday and then a problem like this. It would either be all together or you just have to find the missing things. All right, so we have a triangle, radius 26. Draw the figure if needed. Okay, I'm drawing the figure because I need to see it. Okay, now, okay, this one's really hard, everybody. If it's a triangle, how many sides does it have?
3.
Somebody said 85. Okay, so now our central angle. Well, this is 3. Let's see if I can get a color code going on. So this is 360 divided by 3, which is 120. That means, okay, now I need to draw my apothem right here. That it's, remember, the apothem is perpendicular, makes 90. So what type of triangle, if this whole thing was 120 and it was divided into 2, what do we have now? Yes. It's either one or the two. You have a 50-50 shot of getting this right. Okay? Some of y'all are like, I like those odds. All right. Yeah. So, somebody's over there playing horses again. All right, so if that's 26 and that's the hypotenuse, the apothem, yes. All right. So, what is half of 26?
13.
13. Okay. Now, that's this short side, which is a, now that's the apothem. Now, this, our side length, see, this has got a lot going on. You have to do it like one piece at a time. All right. Well, this is this times root 3. So if that's this segment, our side length, which is both of those, would be, well, what's 13 plus 13? 26 root 3. All right. Yeah, nobody hears you making those weird noises with your mouth, so please keep doing it. It's amazing. So, is he talking to me? What does Mr. Jeffries look at me and that large vein pop out of his forehead? Is he angry with me? All right. So this is 78. And our area would be 1/2. 13. 78. All right, so this would be 507 root 3. All right, so, yes, I know some of y'all are like, that was a lot. Notice there's, there is a lot going on. Please do it step by step. Please don't try to rush all the way through it. Okay? All right. Don't forget, as the in-class audience works on the problems on the back, don't forget, hit like and subscribe to the bell. Good stuff, good things. Roll Tide.